Hello and good evening, everyone. Thanks for joining our Techorama Cafe, powered by our partner Delaware. Before we start with the evening sessions, we also want to share our plan for Techorama 2021. As we all know, 2020 has been a very special year with the ongoing pandemic. The uncertainty has been a real difficulty to plan ahead for Techorama 2021, and finally, we made a decision to move forward and to come up with a realistic plan. Techorama 2021 will be a virtual conference and will be organized in May. The call for papers will be open early next week, and we are confident that we will be able to schedule amazing sessions with top international speakers and local community rock stars. For people with a valid ticket from 2020, we will make it a free virtual conference in 2021, and the old ticket will still be valid for 2022. Where we hope to organize again a full-blown in-person conference with maximum network opportunities. Of course, we will continue to monitor the situation and explore the possibilities with our partners to organize a local event in 2021, maybe later in the year. All right, so that's the big news for today. Let's focus again on tonight and the Techorama Cafe. I want to thank Delaware for organizing this event with us and to stay patient and flexible. Delaware has been our ultimate partner for 2019, and it means a lot for us to have a partner with a strong commitment towards our future events, definitely in these uncertain times. We will kick off Techorama Cafe with a session on infrastructure as code, delivered by Joeri Maes and Tom Vandewinckele from Delaware. After a short break, Gitte Vermeeren from Microsoft will take the virtual stage to talk about DevOps practices using GitHub. Two very interesting sessions tonight, and now it's time to head over to Wouter, who will introduce our speakers, Joeri and Tom. Enjoy.
Thank you. Good evening, everyone. So I'm Wouter, and today I will be looking at the Q&A. So if you have any questions during the session, there's a Q&A tab. Ask your questions there. I will have a look at them during the session, and I will ask them during and at the end of the session to our speakers. And with that, I give the word to Tom and Joeri for the first session.
All right, good evening, everyone. Welcome to this online Techorama Cafe. We are Joeri and Tom. We both have an operational background, and we are thus very pleased to host this session about infrastructure as code for the .NET community. Last year at Techorama, we did meet a few operations engineers, so I hope also some found their way to their online cafe. We're going to start with a quick introduction about ourselves. Joeri, maybe can you kick off?
Yeah, thank you, Tom. My name is Joeri Maes. I have been working at Delaware now for the past 7 years. I have a SQL Server, DBA, and performance background, which was an ideal stepping stone towards the Azure Data Platform. So within the cloud enablement and operations solution of Tom, I lead the Azure Data Platform project, acting as an Azure architect and technical lead to enable data and analytics people to work efficiently and securely.
Thanks, Joeri. So I'm Tom. I work at Delaware since 2014, and I started in our Microsoft infrastructure team. My first assignment was to explore Microsoft Azure as a solution for our team to see what it could mean. And a few months later, the first projects came. So we started with installations of SharePoint, AX, and so on the Azure cloud. And I focused also on our development community within Delaware. So back then, we were already implementing Sitecore on Azure as an e-commerce solution. In the years after that, I started focusing more and more on the development community. And today, I'm responsible of a team of 25 people, which help developers to onboard applications on top of Azure. And of course, we are also very interested to get to know all of you. Don't be afraid, we don't have time for a round table tonight, but we just want to ask you a question about the experience you have with infrastructure as code. So if all goes well, a poll should appear on your screen.
Yes, 1 second. The poll is on its way. I send it, but it's not responding. So give me a moment. I'm quickly re-adding it as we speak. Okay, it looks like the poll is not working for the moment. So we'll, I propose we skip this.
Yeah, thanks, Wouter. So Joeri, please explain all about infrastructure as code, please.
Yeah, okay. So we're going to quickly go about the what and the why. Then we're going to have a look at Terraform and ARM and Azure Bicep. And then we're going to have a look at some demos. Okay, but what is infrastructure as code? Traditionally, when we needed to deploy, develop and deploy an application, there were numerous manual steps. Servers needed to be ordered. They needed to be physically installed. We need to install and configure the operating system, networking, antivirus. Then on top of that, we needed to install and configure a web server, a database management system, configure backups, schedule updates, and all these things happened manually. Now, with the rising of virtualization and public cloud providers, so virtualization from 20 years ago, probably, and then the public cloud providers from 10 to 15 years ago, it started. So the hardware capacity is provided already, and the infrastructure can be provisioned as software, actually. So this sparks enormous opportunities to provision infrastructure in a way that is more scripted and automated. So that is the moment where people started to script out their configuration files in version-controlled source code, in the same way as the application code was already being done for years, and they could be deployed together. Now, when looking at continuous configuration automation tools, there are different tools available for different purposes. When we're looking at Azure resources, which is a bit the focus of today, the big contenders are, of course, Azure ARM templates, which are really specific for Azure. And then there's also Terraform, which is a bit broader, but still focused on the bottom layer. There are other tools as well, like Chef, Puppet, and Ansible, but those are mainly focused already on the layer on top of that, the application there. So the focus of today are the Azure resources, and that is what we're going to have a look at. Now, why would we use infrastructure as code? Because there is a large learning curve, and initial development does take time, but one of the reasons is preventing configuration drift. There are manual actions happening on the servers constantly, and they are not happening on all environments. So this causes the configuration of those different environments to be out of sync, and in the end, that's really a recipe for disaster. We're building up technical debt, and down the road, when there is a deployment, when there is a release, things will go wrong, and people will be working throughout the weekend to get the release into a stable state. This also causes people to start to see their systems as fragile, and they are afraid of changing it. So they're doing releases every 3 months, every 6 months, and when the time comes, again, there is a much higher rate possible for failure, and people are again working during the weekend to get it up and running. People have no confidence in these releases. Okay. Now, when the infrastructure is done in code, these releases can happen confidently because we know that what we deploy in development is the same as what we will deploy on quality and is the same as what will be done in production. And we don't need to fear that things will go wrong. We're also working in much smaller batch sizes, and we're doing small changes, again, increasing the confidence of those deployments. Okay. Now, also, when it comes to IT projects and the infrastructure needs to be provisioned, very often operations is the bottleneck. They need to come first because the infrastructure actually needs to be provisioned. And there are a lot of projects on the roadmap. Next to that, there are migrations planned, there are upgrades planned, and infrastructure really becomes the bottleneck of the organization when it comes to IT projects. When doing infrastructure as code, operations is much more effective, and total throughput of the entire company when it comes to IT projects and delivering value can increase because we work at the bottleneck. Okay, now we see that enterprises that really embrace a DevOps culture and following its principles and using infrastructure as code are capable of doing 208 times more code deployments. And when it comes to delivering features, they do it 106 times faster than their counterparts that are not doing this. Now, when it comes to infrastructure as code, really relevant for this is they are 2,600 times faster in recovering from incidents. And that is really because of this infrastructure as code. The infrastructure can be deployed immediately when things go wrong. We don't care about what is wrong. That can be done afterwards. We just release new infrastructure, run the application, make it available, and we are starting again. Also, I talked about very frequent deployments. Because of that, people gain confidence and we know what can go wrong. And because of that, the failure rate is a lot lower. Okay. Now, if you go to a very concrete example at Delaware, we have the SAP S/4HANA deployments on Azure. When it's done manually, these are deployments that take 3 days of manual labor. When doing it with infrastructure as code, it takes 2 hours. Meaning, in practice, we have around 40 of these deployments a year, leading to 100 man days that is saved. That can be spent on really, again, improving the process or other processes and increasing throughput. So that's one of the practical examples where we use infrastructure as code at Delaware. Now, Tom will have a look at the Azure ARM and Bicep.
Thanks, Joeri. Really impressive, saving half an FTE just on infrastructure as code. Now let's look at Azure Resource Manager templates. So Azure Resource Manager templates is a way to automatically configure and maintain your Azure resources. So next to PowerShell, SDKs, CLIs, this is one of the ways. And we are actually, in a declarative way, defining the resources that we need. And we're doing this through template and parameter files. Why do we have parameter files? Because we want to reuse our templates. Because I think if you're a developer, you're going to build a lot of web applications in your career. And you can use just one template and then reuse that one with multiple parameter files. Let's suppose we're all very good developers and we're not just adapting it straight away in production. We're going to have a test and a quality environment as well. So again, this is another use case for parameter files. The syntax of those files is JSON. We're going to have a look at it later in a few examples. And there's a few built-in functions as well for ARM templates. So first of all, if you're building a web application that is backed by multiple databases, then you don't want to copy your code and paste it right after the other. You're going to need loops, so that's foreseen. If you're going to have a naming convention, you typically are going to need some string operations. You're going to want to split strings, concatenate strings, and so forth. And I believe there's about 30 to 40 functions available to use within your ARM templates. If we now look at a very concrete example within VS Code, this is the ARM template that you need to create a storage account. Now, what can you do with a storage account? This is not something you need for virtual machine disks or whatever. It's a location to store images, videos, tables of data, lists, and so forth. And what is a classic example of an ARM template? It's the fact that it has a fixed structure. So we're going to start with a schema definition. We have a version of our ARM template. And then we have a few sections. So we're going to define some parameters, either inline or by using a separate file. So best practice is to use a separate file. We're going to have some variable definitions that we're going to use to define our resources, maybe to concatenate your naming convention, but it's not something you want to ask as an input to the people deploying your template. We're going to have a section where we define the resources. So in this case, we use the API for storage accounts, and it's the API version that's listed here. we're going to use a parameter function to get the value of the storage account name. And for the location, we're using another function. So in Azure, you create resources in resource groups that are groups of resources that logically are tied together. And we want to put all the resources into the same location as the others, of course. So we just use the location of the grouping. Then we have a pricing SKU, a kind of storage where you're storing images, videos, and so forth. And what do you need if you deploy a storage account? You need a connection string to upload your data. So this is what we set here as an output. My output is called the blob endpoint. It's of the type string. And to get that value, we are doing string concatenations of hard-coded values in combination with dynamic values. So it's very cumbersome to get all of this done. Just to create a storage account, I need already 30 lines of code. You see a lot of quotes, a lot of brackets. And remember this for the next examples. If we now go back to the slide deck, we see an example here of an application. It's called myapp.json. So we're going to create a template file. And to make sure that it's readable, we are going to link towards separate files. So we're going to have a web.json file, which declares our web application. Then we're going to have a SQLDB.json file, which declares our database. Very cool is that you can already pre-fill the settings of your web app with the connection string of your database. But within ARM templates, you need to explicitly define in your web app.json that you are referring to your SQLDB. For all these templates, we're going to have parameter files. Again, because we're going to need multiple environments. So with 3 template files and 3 parameter files per template file, we're going to have 12 files in total to create the database and the web application in multiple environments. And all of this configuration, we're going to store in the Git repository together with our application code. You've seen it's quite a long template just to create the storage account. There's a lot of tooling available to help you create those templates, so you don't have to start from scratch. The first one I wanted to talk about is the ARM Tools extension for Visual Studio Code. So it really helps you while coding. It has some resource snippets, so you can add already pre-completed templates into your template files. It can help you through auto-completion of what you are typing at that exact moment. And it's giving you on-the-fly validation. So typically when you're working with ARM templates, you're going to have a build and release management cycle as well. And within the build cycle, you're going to do a validation of the schema of your ARM templates. So with this Visual Studio Code extension, you can already have it on the fly while writing your code, so you don't have to wait for the CI step. And the extension also helps you with missing parameters or parameters for which you gave the wrong values. So if you expect a string and you put in an object, this extension will point it out to you. Second one I wanted to talk about is the Secure DevOps Kit for Azure. You might have heard of it, but in the field of security, they talk about shift-left strategies. And what it actually means is that we're not going to wait to call a security architect until 2 weeks before the go live to hear that we need to postpone the project for another few months just to make sure that we are compliant with their policy. No, we're going to make sure that we can already work on our security from the first start. And as you can see here at point 1, already at the creation of the Azure account, we can provision some security measures. And this extension is going to help you throughout the lifecycle of your application and the infrastructure until you're eventually into production. So at step 5, you're going to monitor the app, receive alerts, count on some metrics, and you're going to learn. And this learning is eventually going to lead, again, in step 1 and 2 and so forth, to adapt the security of your application and infrastructure. So this is a complete loop, right? And then a third but not least option is the static code analyzer for ARM templates. So what we've seen and what other people might have also observed with ARM templates and the validation step is that your validation often goes through, but when you then actually deploy the resource, it fails. So the validation is not that thorough. The ARM TTK static code analyzer will execute some additional quality steps to improve the validation within your CI step. And there's this pretty nice interface added to the Azure DevOps extension as well. Now there's improvement coming. So Microsoft started early this year with a new language called Bicep. It's still an experimental language, so don't use it yet for production environments. But their main goal is to drastically simplify the authoring experience to create and manage Azure resources. What they actually are doing is creating a transparent abstraction over Azure Resource Manager templates. It's not fully compatible yet, but they aim for a productive release with full compatibility at the end of Q1 2021. And as it's a transparent abstraction over ARM, this means that you can only create Microsoft Azure resources. So to clear out, Azure AD and Azure DevOps is out of scope, both for ARM and for Bicep. So what you're actually doing is writing Bicep code, and then you're compiling it down to ARM. So this is also visually represented on the right-hand side. This means that some of the tooling I just presented is still very valuable also in scenarios where you're using Bicep. Now, what has actually been improved compared to ARM is that it's a much simpler syntax. So we have no more brackets, no more concatenations and so forth. There's a much more modular structure included compared to linked templates. We don't have to explicitly mention that we have dependencies on other resources. So during the compilation of your Bicep code, the explicit mentioning of the dependency is added for you within the ARM template. We have a richer validation and IntelliSense available through the Visual Studio Code extension, and we lose the fixed format. So you have a flexible declaration of types within Bicep. We're now going to have a look at both a Bicep and a Terraform example as an entry point for Joeri to explain Terraform. But first, we're going to have a look at Bicep. So where we had 30 lines of code to declare our storage account through ARM, we here have 12 lines of code. You can see less quotes, less brackets, and it's much more readable. So what we're doing here is we're defining a parameter. It's called storage name, and it's of the type string. And I gave it the value Techorama 2020. And then we're defining the resource. So it's called STG storage. And we're using the same API as we did before. Note that you already needed about 3 lines to set this, which is now 1 line. And we needed about 4 to 5 lines to define the parameter, which is now also 1 line. So we're using the parameter which was set here above without using any ARM functions, as it's called. So we can just use it here. Then we still have this function to select our data center, and we have the kind and the pricing SKU. Also very nice to see is that the output, being the connection string to our storage location, is way more easy. We have no concatenations of hard-coded values anymore, and VS Code is really helping us out, which is not possible through ARM. If we go into our storage account properties, you can see everything that's available through the API until we have defined what we need. And actually, Terraform is very simple, very comparable to Terraform. So Bicep actually uses some principles that Microsoft has seen being used at Terraform. And this is what it looks like. So it's also very short. We have 11 lines here. We define our resource with the necessary parameters to create the resource. And then we have a very easy definition of the output. So we are very interested to hear all about Terraform, Yuri.
Yuri, you're still muted, I guess.
Yes, so you should be seeing the presentation now from my side. Okay, now we're going to have a look at Terraform, another way of configuring resources on Azure, but also in a broader sense on a lot of other cloud platforms. Okay, so it makes use, rather than using the Azure Resource Manager, it makes use of the REST APIs by Azure or any other cloud provider or other provider that is used within Terraform. Okay, in that way, it is also capable of deploying towards multiple providers, specifically for Azure, that is already for Azure Resource Manager, but also Azure DevOps. It is possible to provide Azure DevOps projects and service connections and YAML pipelines within Azure DevOps using the Azure DevOps provider by Terraform. Next to that, there is also an Azure AD provider. And this gives a huge advantage compared to ARM templates, because in ARM templates, we cannot provision, for example, service principals and such, which we need for authentication between different components. Okay, that's one of the big differences between ARM templates and Terraform. It makes use of the APIs, and using the APIs, it checks what exists on my system. Do I need to create something? Do I need to update something, or do I need to delete something? Okay. Next to that, there is also a state file, and the state file contains the Terraform state, being all resources that have been deployed by Terraform. Compared to ARM, where the Azure environment itself is your state, and it compares that with your templates and then figures out what it needs to do. Terraform compares it with the state. Okay. Terraform compares it with the state and then checks what it needs to do. Of course, it is capable of also looking at the environment to see if nothing has changed. So if anyone has configured a value differently within your environment than it is in the state, it will refresh when you do a new deploy. Okay, so that is Terraform, but now it's time for a demo. All right. So for this demo, we're going to have a look at an Azure data platform that we're going to deploy. And what are we going to do there? We're going to read some data so that platform serves to read data from some on-premises data sources, processing it with Azure Databricks, and then writing it towards an Azure Data Lake and an Azure SQL database. So how does that environment look like? We have Azure Databricks, of course. We want to reach on-premises resources, so we want to go over the private network. So we will need a virtual network. And in there, we will deploy our Azure Databricks cluster. Then we also need, of course, the data lake, which we will write the data, and the Azure SQL database. For orchestration, we will use Azure Data Factory. We will also add a management virtual machine just to connect securely towards the SQL database through a service endpoint, for example. And to connect actually to the management virtual machine, we will deploy Azure Bastion. Now, for managing the environment, just to make this a bit of a better approach, we will also make sure that we have an automation account to, for example, execute maintenance on the Azure SQL database, but also auto-scale or auto-pause some resources. We also have a key vault for storing the secrets, and just a generic storage account on which we will store our scripts for the automation account. Lastly, we will have a log analytics workspace, and all logs will be sent towards there. So this is one of the advantages of Terraform. We can define a module, and in that module, we can not only provide, for example, one storage account, but we cannot just provide a virtual machine, but we can also provide the backup for that machine, the logging for that machine, any service principals with specific actions and roles that need to be available there. So we can configure this whole environment in a best practice way. Also backups, for example. So that is what we are going to do. Okay. I am looking now at Visual Studio code. And what you will find here is a parameter file that I will use to deploy this environment. And what you see here are 3 folders. We have a parameters folder, a pipelines folder, and a Terraform folder. So the parameters folder is just indeed 3 parameter files for our different environments containing the parameters for that environment. We'll briefly go over that in a minute. We also have pipelines because normally I'm doing it now through Visual Studio Code, but normally we deploy these things through Azure DevOps, for which these pipelines in here are used. So these are YAML pipelines. And next to the deployment pipelines, we also have some testing pipelines. Because when we are making changes to modules and those modules would interact with each other, we want to prevent them breaking changes to the modules. So as soon as someone makes a change to a module and commits it, there is a test being done to validate all modules again. And then during the night, we actually execute the deployment of a number of test parameter files. So at that moment, there are really 10, 15, 20 deployments actually being executed, check that we have all the resources, and then broken down again. And this makes that we have a very robust and stable modules that we have developed. Then we're talking about Terraform itself. And there you have a main file, and it's that main file that you call during your deployment. And it's compared to just the Azure ARM template file. You call that together with the parameter file, and your entire environment that you want to deploy gets deployed. Now, within this main file, it is possible to call specific submodules and submodules and submodules, like it is possible in Bicep, but it's a bit more difficult within ARM with these linked templates. It can be quite cumbersome. So that is what we do. Within our main template, we call these submodules, and we have modules for Azure SQL, analysis services, Databricks, so a lot of the components that we mentioned earlier. Right, so for example, Azure SQL, what happens there? There is the SQL itself, there is the databases. It is possible to auto-scale there. There is the backup that gets configured, the diagnostic settings get configured, audit get configured, Azure Defender gets configured. So all that is done within one module to make sure that with a minimum amount of parameters, we have a best practice setup. So that is what we're going to actually do now. So what we need to do, Terraform works in different stages. First of all, we need to initialize our environment. It will check what providers we are using and make sure we have the necessary binaries for actually executing that. So first of all, we do Terraform init in our Terraform folder. It sees that we have a main file here, and it checks what we are all using. So it sees, for example, okay, Azure RM, so Azure Resource Manager provider is used. We use the random provider, and we also use the template provider, because that's also one of the things of Terraform. If you use preview features or features that are just new within ARM, they are not immediately available. Someone needs to develop those in Terraform, needs to add them. So they lag a little behind, and that's why there is still a necessity to deploy ARM templates within Terraform. So we see that our environment.
Joeri, but we have a question from the audience. If you can zoom in a bit on your code you're showing.
I can have a look. Can I? Okay. Is there a way to make this bigger? Okay, so I'll just use the following command, and then I'll have a quick look to zoom in. What we now can do, we have initialized our environment, and we will now have a look to really deploy those resources. Now we can do 2 things. You can say Terraform plan to see what it is going to do, or you can do Terraform apply. And Terraform apply really applies the resources, but first it will do a plan and show you what it's going to change. So every apply also incorporates a plan. So that's what we're going to do. We're going to say Terraform apply. it knows we're deploying this main template here, but we still need to say which variable file we are using. So that's Terraform apply, and the var file equals then, this is a relative path. We go one up parameters / dev.tf vars, which is this file then. Okay, and if we apply this, it will check what is in there, what do I need to deploy. I'll have a look here.
The audience let us know, Joeri, that Control+ is your friend.
Okay, yeah. Is that already better? Okay, it should be a lot better now. So this is actually the parameter file that we're trying to deploy, and behind that we have all the modules that we're calling, like the Azure SQL module, like the Databricks module. We're all calling these through this main file. Like, okay, we're requesting some general information in this parameter file, like the location where we want to deploy. We also need to provide an application and a tier, which will be used for the naming convention. And then there are just some true-false variables here saying security, true. And if that is enabled, we will enable the Azure Defender extension where possible, meaning on the virtual machines and also on Azure SQL. So advanced data security, that is enabled at that moment. When it comes to alerts, if it's true, we will also send out alerts towards the contributors of the resource group that we're going to create. The same for logging. If we set this to true, it will enable all diagnostic settings on the resources that we're trying to deploy. And when it comes to backup, it will also additionally backup in a recovery services fault. Okay. What we have seen in the meantime here is that our apply has started, and it says, okay, I have planned the environment. I'm going to add 103 resources. I'm going to change 0 resources, and I'm going to destroy 0 resources. Do you want to perform these actions? The answer to that is yes, and we press enter. So at this moment, it is really starting to call the Azure REST API to actually deploy all the resources that we have here. And if we go to those actual resources, so they are at the bottom here in this parameter file. Okay, so first, we have a number of tags. We want to add these tags to every resource that we're deploying. And next to that, we want to generate a name for all our resources. And that name is comprised of first the location, which will be an abbreviation of West Europe, which we have defined here. The application that we have defined at the top, the tier, which is also defined here, then an abbreviation of the resource, and the count of that resource. So we keep a list of the resources and their abbreviations here also in a file, which is called along with the other parameters. So here you can see, for example, we have a complete list. We deploy a virtual machine with AVM as an abbreviation. We have Cosmos DB as CMA. We have a virtual network, that's Azure Virtual Network, AVM. So in that way, it will really generate all the names of all our resources. We can rearrange these. We can add fixed values between there. And then it also takes into account, for example, a storage account. You're not allowed to have dashes there. It will remove the dashes if you have put any fixed in there, and it will remove them. Okay. Then we call specific modules. This is just a list of what we want to deploy, and we have defined calling these modules within the main. Within our main module that we're actually calling. Now, the clearest example is just, for example, the virtual machine here. It is an array. We call the virtual machine module X times, and we're just going to deploy a virtual machine with a specific size, within a specific subnet, and with a specific image. Now, the subnet and virtual network is actually defined here. In our base, so that this is a whole list of saying, okay, we're going to have this virtual network. We want these NSGs, these route tables. So that can all be defined in here. And this is just a prerequisite for our virtual machines. We just say then, okay, we want it to be in this subnet, this image, and we want it to run on this regime. So in the automation account, there is a script that executes and checks the tags. And during the weekdays, this VM will run from 8 o'clock until 8 o'clock in the evening. Now, we want, for example, more virtual machines. We just need to copy, paste, and we have more virtual machines here. Now we have 6 instead of 2. If we would redeploy this after it created everything here, then we would have more virtual machines that will be deployed. Okay. Next to that, we also deploy Databricks. There are some specific parameters here. We deploy Azure SQL, Data Factory, and Bastion. The other components are comprised in our base module, which we consider resources that need to be deployed within every deployment, actually. And if we go to our Azure environment now, we will normally see, we will already see the resource group in which everything is deployed. So this has just been created, and we see that the deployment is actually happening as it is. So we're not seeing, for example, Data Factory yet, but what we do see is our automation account, an automation, the SQL maintenance, actually, Azure Bastion, a public IP for Azure Bastion, the storage accounts, the key vaults, the route tables for the virtual network, the virtual machines, Azure Databricks. So all our resources are actually here. And if you look, for example, at the diagnostic settings, it's probably deploying a few of those already now, but most of those are enabled. So all resources really have their diagnostic settings towards that log analytics workspace set for proper logging of that system. Next to that, we have our recovery services vault, and we had backup true. So the backups that are the virtual machines that are deployed here are also backed up towards this recovery services vault.
Sorry to interrupt you again, but there are some users that are still, or at least we're still seeing your Visual Studio Code. Looks like it's the portal that's visible now, but maybe you can wait a bit longer on this screen so everybody can have a look.
Yeah. Okay. Right. Right. So very important to mention here is that within these modules, it's really possible to make a best practice implementation. For example, with Databricks, next to deploying the Azure Databricks workspace, we also deploy a service principal for accessing the Azure Data Lake, which can then be used to mount the data lake towards Azure Databricks. Also, the role assignment of that service principal towards on that Azure Data Lake resource is also created here. And next to that, there is, since half a year, I think, there is the Azure Databricks provider for Terraform, which makes that we can also create the cluster itself within this single deployment. Right. Did everybody see already the screen now? Because I would go back to the presentation.
There's the request to also zoom in on this one before you switch over.
Okay. So this is a list of all the resources now that we have deployed. There are probably already more in the meantime. Yeah, there is. So in the meantime, we have our SQL Server. We also have our SQL databases that were defined in the code. And that's it. I think Data Factory, and then the configuration of Bastion, which always takes around 15 minutes, I think, is still on its way. So let me go back to the slides. This is just a summary of what we have discussed. So when it comes to the platform, ARM and Bicep are configured, are just Azure only, while Terraform is more generic. Terraform and Bicep are easier to use than ARM, I would say. And then they are also very good at modularizing things in compared to ARM. So all in all, Bicep and Terraform, we're preferring those compared to ARM, but of course, Bicep is currently not in production. So soon, when Bicep is production ready, we really see this as a game changer for deployments. Right. You also have a list of a bit of reference documentation. You can find the slides on this GitHub page, and you can find some general documentation in here. Now, don't hesitate to reach out to us if you have any questions or want to know more. Right, so thank you for everyone's attention and time.
Thank you, Joeri. Maybe because there's a lag on the screen share, if you can open up the references again, that slide, so everybody can definitely have a look at that one while we go to the questions. We have several questions from the audience. I'll start with the one with the most votes. It's from Anton. He asked, how can you add environment-specific prefixes, postfixes from a parameter file to the resource name without the concat function? I believe this is about the ARM, but yeah, maybe to answer it for all of them.
Yeah, I think so too. It was asked for ARM. So it's actually not possible. Either you put it hard-coded into your parameter file per environment, or you need to use the concat function within ARM. So for Bicep, it will be fixed. You will be able to do so without using functions. So you can define parameters across your files and use them in other files within your modules. For Terraform, it's likewise, Joeri. You can also more easily do so. I think you've all seen the demonstration of Joeri on how he is dealing with naming conventions. That was very flexible.
Yeah, so we do need some concatenations there, but when it comes to referencing other resources, it is just it's done in an object-oriented way. You have your resource that you're getting out of it, and then there are several outputs there defined. So you just say, for example, my storage account .id or .name, and then you get the name, and you can use that for in other resources to reference them. As for the naming, what we're doing is interpreting that string and generating a general name where we then replace the specific resource and the count.
Okay, thank you. I think we can mark that one as answered. I'll jump to the next question from Robin. How do these ARM templates fit into Azure Blueprints? When to use which one?
Yeah, so Azure Blueprints is actually a wrapper around ARM templates. So you can use just solely ARM templates, or you can use them as an Azure Blueprint. But then again, it's composed of ARM templates. The idea of a blueprint is that you can actually, as an IT team, you can offer it towards the rest of the organization. So for example, if you have a development team that often uses, to come back to my example, a web application with a SQL database, then you can offer them an Azure Blueprint within the Azure portal, and they can just easily deploy it. So next to the pure infrastructure then, you can add in Azure Blueprints also, for example, Azure Policy, which then, for example, allows developers only to create resources in certain data centers so that they don't create or don't put data in Asia or US or whatever because of GDPR restrictions. Blueprints is composed of ARM templates, but it goes a bit broader than just the resources. So you can add a lot of policies as well.
Okay, thank you. Having a look. Then the main other question is if there will be slides available afterwards and if there will be code available in GitHub. I can answer that one myself. So the slides are available on GitHub, and some of the code shown today will also be shared there. Unfortunately, we cannot share everything that has been shown today. Seeing if any additional questions come in. No.
I see whether someone got a 404 browsing to the Git repo, but I just tried it in an incognito tab and it worked for me.
Yes, I just fixed it in the meantime while you were doing your explanation, so it should be available now. The repository was still in private mode and not in public, so these are now available. Okay, I also see that we're at our time, so thank you very much, Tom. Thank you very much, Joeri. We will be back after a short break. That's 7:05 with the next session given by Gitte.
Okay, and don't forget to rate the sessions for today. Thank you and see you soon.